Hey guys. So I was working at the cheese factory yesterday, and this group of scientists come in and they tell me physics jokes. You guys want to hear it?
Sure.
Okay. So the Higgs boson particle walks into the church, and the priest tells him, "You can't have bosons in here." But the Higgs boson is like, "But with me, you can't have mass."
Do you mean without me you can't have mass?
Yeah.
Nickel, I think it's time for me to bestow my knowledge of physics upon you.
Oh boy.
You walked right into that one.
Research Journal. Entry 1. I'm about to embark on one of the greatest challenges of my scientific career, teaching nickel physics. I'm calling it Project Gorilla.
Hey Shelly.
Come in, have a seat. Subject appears well rested and enthusiastic. Apparently ignorance is bliss. Alright, let us begin. So, discovered as recently as July 4th, 2012, the Higgs boson particle is the last fundamental piece of the standard model of particle physics, discovered experimentally. But what is the Higgs boson particle, you might ask? You should be taking notes. Let's see. How to explain the Higgs boson without getting into the entire quantum mechanics of it? A challenge indeed. So let's start at the basics. There are really only 4 types of forces in the universe: strong and weak nuclear forces, electromagnetism, and gravitational. And there's only 3 types of particles, which is remarkably incredible because really the entire universe is based upon it. One of the many things that quantum mechanics has told us is that fields don't exist the way that we thought, such as force keeping 2 magnets apart. Instead, it's more of a fog of photons, a distribution of particles that radiates from the point source of the magnets. Forces are carried by these virtual particles. These particles are difficult to conceive because they're snapping in and out of existence. Yet all these forces have these force-carrying particles, and they all have a point source to which they emanate. None of this could ever explain why matter has mass. Some of these things have no mass, like photons and tiny amounts of electrons, while others, like top quarks, have so much mass. So is it because of their size? No, because they're the same size, or they're size-less. They don't have any volume.
Wait, are you saying I can lift anything no matter what size? Are you saying I can bench press 500 pounds?
No, but excellent analogy. Without mass, the particles of those weights could all behave like photons and travel at the speed of light. What keeps them dense, what keeps you dense, is their interaction with the Higgs boson particle.
Are you calling me fat?
In the 1980s, a team of scientists, including Peter Higgs, agreed that there must exist a field of particles permeating around the entire universe evenly, not just from a point source like other forces. With this Higgs field fog, some particles would interact much more with others, giving them more mass. The boson particle is an integral part of this process, and not the entire part that gives matter mass. It is the observable part. Given the right circumstances in a closed system in a particle accelerator, such as the one given in CERN, we can find this force carrier particle for mass. Do you understand?
Oh.
Okay, how do you not understand? I just explained it to you. Have you recently suffered a blow to the head?
Hey, you don't have to be so mean.
Okay, I'm sorry. Have you suffered a recent blow to the head?
No, I just... trying to understand, but it's just... You're talking way too fast. Let's take it a little slower.
Okay, so there were only 4 types of particles in the universe.
No, I mean about the Higgs boson part. Isn't that what you want me to learn?
Or perhaps the proper way to tackle this challenge and this great scientific discovery is to maybe perhaps teach you the whole entire quantum mechanics.
Oh no.
Physics, quantum electronics, quantum optics, and this all relates to quantum theory because it says
Number 5?
Oh God!
Are you still teaching?
Project Gorilla has encountered complications.
Think of Higgs boson this way. While some people eat burgers, they get fat, while others do not gain mass. Everyone reacts differently.
Oh, I get it. I get the joke. Without me, you can't have mass.